Hi, I'm Nicole Hellessey and I'm an Antarctic marine scientist. And today I'm going to be telling you about the animal that I study. It's a crustacean, kind of like a prawn, but it's called krill. And they're only very small. They're about 6 centimeters long, which is about as big as your pinky. And they're really, really important for the entire Antarctic ecosystem because all of those lovely big animals that live in Antarctica love to eat krill. So some of the animals that like to eat them are things like penguins. I love penguins. This penguin is a baby emperor penguin and it's got lovely grey soft feathers. But the biggest animal that likes to eat krill are things like blue whales, and they are absolutely huge. They're about 20 to 30 meters long. Now, today I'm going to be telling you a little bit about what krill eat. Now, krill are only really small, only about 6 centimeters long. So what kind of small things do you think krill might eat that live in Antarctica? So some of the small things they eat are things like fish eggs and squid eggs. They also eat little insects that live in the water called copepods that are only about 1 to 2 millimeters long, so they're really, really small. But their favourite food is algae. Now algae is sometimes called phytoplankton, and that just means that they're a plant that grows in the ocean that's really, really small. So today I'm going to be showing you an experiment that you can do either at school or at home, and it only uses very few things, and it's all about where the ice and the water at the top of the ocean are. And that's because all of those plants that the krill like to eat, all that algae, lives in that very, very top layer of the ocean, right where the ice and the water meet. So for this experiment, all you're going to need is a spoon, 2 glasses, but make sure that they're the sort that you can see through. That's really, really important. You need some salt, some food dye. I've got blue, but you can use whatever colour food dye you like, and some ice cubes. And that's it. That's all you need. Let's get started. So the first thing we need to do is we need to take our 2 glasses and we need to fill them up with water to about the same level. So I'm just going to go and do that and I'll be right back. So once you have your 2 glasses with water in them, you need to pick which one's going to get salt in it. So I'm going to use this glass and put some salt in it. So you need to take your spoon. Now it needs to be a big spoon, like a dessert spoon or a soup spoon or something, because we need a lot of salt, because what we're going to do is make this water hypersaline, and that just means that it has a lot of salt in it, because hyper means a lot. So let's put, oh my goodness, a lot of salt in. And we need to stir that in until it's fully dissolved. So I might stir this and come back in just a second. Okay, so that's about as dissolved as I'm going to be able to get it because of how much salt I added. So it's pretty easy to tell that this is the salty one because it's got that little bit of a white colour to it. So the next thing that we need to do is put our ice cubes into the water. So I'm going to put 2 ice cubes in there. And let's get 2 nice. Yep. 2 ice cubes in here. There we go. Now, obviously this one is nice fresh water, whereas this one is salt water, kind of like what the ocean is. And these ice cubes are basically representing the icebergs or the ice in Antarctica. So like I was talking about before, that top part where the ice and the water meet is really important for the plants that live in Antarctica that the krill eat. So the reason it's really important is that's the area that gets the most sunlight because it's at the top. But it's also where all the nutrients from the earth, where Antarctica is, the actual dirt and the land, is right up at that top as well. It's also where all of the nutrients that get brought up from the bottom of the ocean come up to. But it's also where the ice melts. So we're actually going to be doing an experiment looking at the ice melting. So now you need your food dye, and we're just going to put a few drops . Now you can already see that there's a bit of a difference in how that food dye is mixing. So in the salt water, it's all kind of staying up near the top there, isn't it? Whereas in the fresh water, it's all mixing down here. And there is a little bit mixing over here. But most of that food dye is staying up near the top. So that's really different, isn't it? You can see this one is definitely keeping all that food dye right at the very top. Whereas the fresh water, there's not much there, is it? So why might that be? Why would all of the food dye be staying right at the very top of that water? Well, it's because in the fresh water, all that water can get into all the little nooks and crannies and holes and bubbles in that ice. And it can actually start to melt the ice from the inside, which makes the ice not only melt faster, so you might not be able to see it in this video, but the ice cubes that are in here are really, really small at the moment, whereas the ice cubes over here are still huge. So not only are they melting faster in the fresh water because that water can get inside, but the water's also mixing a lot more. Whereas in the salt water, not only are our ice cubes still really, really big, but they're not melting as quickly either. And that's because the salt can actually plug all those little holes and gaps in the ice. Those salt crystals are actually big enough to plug those holes up in the ice, which is pretty cool. But it means that when they do melt, they melt really, really slowly. And of course, fresh water is less dense. It's not as heavy as salt water, because obviously salt water has all that salt in it and makes it a bit heavier than the fresh water that doesn't have any salt in it. So it sits up the top. So all that fresh water starts to pool and gather at the top of the water. And that's that really dark blue that you can see with that food dye that we put on the ice cubes. But we know that the fresh water can get into the ice cubes and melt it faster. And now there's this concentrated layer of fresh water right at the very top where this ice is. But it's also really cold because it's only just freshly melted off that ice, whereas over here it's melted and mixed. So this water is going to be an average sort of a temperature because it's part of that normal water that was just sitting there at the room temperature, plus that little bit of cold water from the ice melting. Whereas this one, it's going to have a really concentrated cold water at the top with this warmer water underneath. And that's really important for those plants that live right where the ice and the water meet, because they like the water to be colder than the warm water underneath, but they also like the water to be fresher than the water underneath. But they also like to stick to the ice in the same way that those salt crystals do. So even though they like the water around them to be fresher and they like the water around them to be colder, they actually want the ice where they are to be slightly saltier. And that gives a really weird balance to what kind of plants like to live on the underside of that ice. And it's really different to the kind of plants that we see in warmer waters or in fresher waters. So that's my really fun little experiment that you guys can do at home. And you'll be able to see how icebergs melt differently in fresh water and in salt water. Have fun!